Hi, and welcome to Allen High School's discussion of solutions at the pre-AP or 10th grade honors chemistry level. We've been discussing various solutions. How do we know whether one substance will dissolve in another substance? And now what we want to look at are changes in some properties that occur when a solute dissolves in a solvent. The first one we're going to look at are really the only one we're going to look at right now is colligative properties, and the two colligative properties we're going to look at are changes in our freezing point and our boiling point. So if we have a freezing point and a boiling point of our pure solvent, once we add a solute, what happens is that the boiling point will be elevated. So the boiling point will go up and the freezing point will go down. So we call that boiling point elevation and freezing point depression. So this would be for the solution. SOLN is short for solution for me. Okay, now this change, this difference that we see is proportional to the amount of solute per given amount of solvent. Okay, we're only going to talk about it qualitatively. We don't calculate this anymore, so we're not going to talk about the specific ways of measuring this because there are many. We just want to talk about the amount of solute per solvent, and if it ionizes or dissociates, we have to multiply that by the number of ions or the particles. So that's why we introduced you to I earlier on. So the take home here is if you increase I, you increase the change in the boiling point going up, and your freezing point becomes much lower. So this is why we put salt in our spaghetti water. People think that it makes it cook faster, and it doesn't. It takes a little longer to get it to boil, but once it's boiling at a higher temperature, so it will boil faster at that point. It will cook at a higher temperature, but it takes a little longer to get the water to boil. Now, the reason we put salt, and we've had some storms that are indicative of this, the reason we put salt on our roads is because it lowers the freezing point and causes this ice to melt at a lower temperature. So that's the gist of our colligative properties. So let's take a look. Let's fill in some of these blanks here. So why do we care about I? Because I is going to alter the colligative properties. Colligative means it depends only on amount, depends only on the amount of solute, not necessarily on the identity. And we just saw that we have boiling point elevation, and we have freezing point depression. Okay. Now, and I've really already mentioned all of that, so let's forge on ahead. Now, when we do this, you want to be able to calculate I so we can decide what will be the most cost-effective ways of achieving our temperature of our solution. So if we look at this, which substance would have a greater change in the freezing point and boiling point? Okay, so as you increase I, you will increase the elevation of the boiling point, and you'll make the depression even more depressed. You'll make it even lower. You can think of it this way, you will increase the change in the temperature for your phase transition. So it makes it lower if it's freezing, and it makes it higher if it's boiling. So the greater the I, the greater the change. So that would be I equals 4. Magnesium chloride is used. Why? as long as they have the same given amount of solute per solvent, I for magnesium chloride is 3, I for sodium chloride is equal to 2. And what we would get then is the one with the greater I would have the greater effect. So magnesium chloride tends to be the one that will change it the most. Okay? Now, let's take a look at our next conversation here. This one gives us a specific way. We're going to talk about this in more detail. This is called the molarity, and we're going to calculate this soon. It's moles of solute per liter of solution. All right. Now, since these both have the same moles of solute per liter of solution, what we want to do is compare I. Well, glucose is covalent. It's molecular covalent. And I is equal to 1 for all molecular covalent. You don't dissociate a covalent. I know some students will add up 6 and 12 and 6, but we're not breaking this into carbons, hydrogens, and oxygens. It stays as glucose intact. Don't dissociate covalent molecules. So I is equal to 1. Well, KOH is a strong base, so I'm going to get potassium ion and hydroxide ion, and so I is equal to 2 for that one. And so the greater the I, the greater the change. So the greater the increase in the boiling point and the greater the decrease in the freezing point. So it would be KOH would be our winner because I is equal to 2 for KOH. Okay, so hopefully that gives you some insight, and I can give you more insight in class as needed. So until then, this is, as always, signing off.